So this video, we are going to solve a related rates problem for calculus. So the first step for any calculus problem or word problem is just to read it, right? So after you read it, I would recommend drawing a picture. So ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So lots of words, lots of numbers, and we're asking ourselves what's going on. So first step is just to draw a picture. So here's a wall, here's the ground, and here's the ladder. So the ladder is resting against a vertical wall. So here's my ladder. And it tells me that the ladder is 10 feet long. So this is 10 feet here. It's resting against a vertical wall. If the bottom of the ladder slides away from the wall, so this ladder here is going to be, pretend this is my ladder, it's going to be sliding away like this. So as it slides away, it's dropping down from the vertical wall. It's moving towards the right, the bottom of it. So if the bottom of the ladder slides away from the wall, so here's the bottom of the ladder, it's sliding away from the wall at a rate of 1 foot per second. How fast is the top of the ladder sliding down? So this ladder is going down as the bottom is going outwards, right? So let's go ahead and start giving these lengths here some names. So I'm going to call this X and I'm going to call this Y. You could have called it W, Z, or whatever you want, but I called it X and Y. It says that it slides away from the wall at a rate of 1 foot per second. 1 foot per second is a rate. Whenever you see a rate, that means it's a derivative. So the derivative of x is going to be dx dt. So dx over dt with respect to time, the rate is always the position with respect to time. So when you take the derivative of this, it says the rate is going to be 1 foot per second. 1 foot per second. So that's what's given. What's given is that dx dt is 1 foot per second. And also what's given is how fast is the top of the ladder sliding down from the wall when the bottom of the ladder is 6 feet from the wall. So actually I'm going to write that as a find. What do we need to find? So we want to find how fast. How fast is a rate? So we want to find the rate that this thing is going down. So this is y, so the rate is going to be dy over dt. So I want to find dy over dt when the bottom of the ladder is 6 feet from the wall. So when this x is going to be 6. X is the distance when x is 6 feet. So step 1 was drawing the picture, writing down what's given, and what do you need to find. And oftentimes when you draw the picture, you have to assign certain variables to it. And whenever you see the word rate, that means derivative. Okay, so step 2. So for a related rates problem, the next step is to write an equation that relates, that's why it's called related rates, that relates the variables above. So here, this is a picture of a right triangle. So a right triangle, we know we could use Pythagorean theorem, which says the leg squared plus the other leg squared equals to the hypotenuse squared. In other words, x squared plus y squared is equal to 10 squared. Write an equation that relates the variables above. Step 3. Step 3 now is to find the derivative of the above equation with respect to time. WRT with respect to t, time t. So when I take, this is using implicit differentiation. So to take the derivative of x squared, we get 2x. And then since we took the derivative of x, we're going to have to write dx over dt, because with respect to time. Plus, the derivative of y squared is 2y. And then we take the derivative that's with respect to time is equal to the derivative of 10 squared, or in other words, the derivative of 100 is simply just 0. So now at this point that we have our dx dt's, our x's and y's, now we can start plugging things in. So now plug known numbers in. and solve for, in this case, we want to solve for dy dt. Right? So we have a dy dt here. So we should know our x, dx dt, and y in order to solve this. So 2 times x, so what is x? X is given to me as 6 feet. Dx dt, that's the rate of change of x, which is 1, plus 2, and then I have y. Uh-oh, what is y? So let's find out what y is. So I'm going to go on the side real quick. What is y? Well, if we know that x is going to be 6 feet, then we can find out what y is, again, using the Pythagorean theorem. So here, if I know that x is 6 feet, my ladder is always 10, and this is y, I can find out what y is. So here, using the Pythagorean theorem, y squared plus 6 squared equals to 10 squared, I end up getting 6 times 6 is 36, 10 times 10 is 100, so y squared equals to 64, so y is equal to plus or minus 8. And it's a length, so it's always going to be positive, so I'm just going to use the number 8. So here, y is going to be 8. So 2 times 8 times dy over dt is equal to 0. So I plugged in all known numbers, and now I just need to solve for dy dt. Okay, so I'm going to put this in bracket just to say that this was my side work. Organization is key when you're doing long problems like this. So 2 times 6 will give me 12, plus 16 dy dt is equal to 0. I want to solve for this, so 16 dy dt is equal to negative 12. So dy, oh gosh, it's really hard to write with one hand holding the camera. I end up getting negative 12 over 16. And if I want a decimal answer, negative 12 over 16, if I plug that into my calculator, I end up getting 0.75. So actually negative 0.75. So, and dy dt is a rate of change, so it's going to be negative 0.75 feet per second. Okay, feet per second. And why is it a negative? The reason why it's a negative is because this rate of change, it's going downwards, right? So when you're moving downwards, it's going to be a negative. So that's why it's a negative 0.75 feet per second.